Hello students, welcome you to this video. In this video, I am going to teach the concepts of permutations and combinations. So many students, they find this topic difficult, when to use permutation, when to use combination. Just I am going to briefly explain the difference between permutation, combination, and what are the formula and what type of sums you can do in this one. Okay, that is the aim of this video. Okay. So basically the permutation, suppose for example, you have three books, a maths book, physics and chemistry. Suppose you have three books, maths, physics, chemistry. So I'm asking you to take two books without seeing. The three books are in a bag. Without seeing, I'm asking you, you take two books. Okay, select two books from this. So what are the possibilities? When you select two books, sometimes you would have got maths and physics, or you would have got physics and chemistry, or you would have got maths and chemistry, right? So which books you got? It means you will say I got maths and physics, or you say physics and maths, both are same only, you got two books. Okay. Now suppose I'm asking you to, you take two books from the same lot, okay, from the same bag. I'm asking you to take two books and arrange it on a table, one above the other. First one, just I am asking you to take two books, that's all, select two books. Now, take two books, first you select two books and arrange it on the table, one above the other. So, suppose you are getting maths and physics. Now you have a doubt, which one to keep below and which one the top, right? Suppose you can arrange maths, physics or physics, maths, right? That two books itself you can arrange like this, maths, physics, maths. Or physics, chemistry, chemistry, physics. Maths, chemistry or chemistry, maths. So, selection can be done only in three ways, whereas arrangement can be done in how many ways? 6 ways. So, in arrangement, the order is important, right? So, you know what is order in the ordered pair. There, the order is important. In a set, you write 1, 2 or 1, 7, or you say 7, 1. Both are same only, right? But in ordered pair, 1, 7 and 7, 1 entirely different, they are not same, right? So some cases the order is important. So in arrangement, the order is important. Okay, so whenever arrangement, the order, it is important. We look into the order, we look into the arrangement, there we have to use permutation. Order is not important, just we select two things, that's all. There we use combination. Suppose there are 5 points, you have to draw a line. Suppose the points are A, B, C, D, E. How many lines can be drawn? To draw a line, you have to connect how many points? 2 points you have to connect, right? So I'm drawing AC is a line. You can't say CA is another line. Both are same only, right? Here order is not important. Just what? AC. You are selecting 2 points and you are joining, that's all, right? A and C or C and A, both are same only, right? So it is only selection. In such question, you have to use what? Combination, okay? So when the order is also important, there we have to use permutation, okay? So briefly, I'll explain few sums also. But if you want to learn this topic thoroughly, permutation and combination, basically you need factorials. See, what is factorials? See, 5 factorial means it is 1 into 2 into 3 into 4 into 5. This is 5 factorial. Suppose 3 factorial. 3 factorial means 1 into 2 into 3. So what is n factorial? Factorial means you start from 1, 1, 2, 3, continue till you reach that number, right? So n factorial means 1 into 2 into 3 into etc. up to n. The previous number n minus 1, okay? Right, this is the one thing. And here you have to remember 0 factorial is assigned value, it is 1. You have to remember, take it as a result. 0 factorial is 1, okay? 1 factorial, that also 1 only. So you can't say 0 equal to 1. So it is an assigned value, okay? 0 factorial, you take it as 1. Based on that only, we derived a lot of derivations, okay? Now please listen here. The next important result what I want to tell you. Suppose if I take these 5 separately, what's the remaining? 1 into 2 into 3 into 4. And that is same as what? 4 factorial. So, 5 factorial can be written as, if I take that 5, what is remaining? 1 into 2 into 3 into 4, that is what? 4 factorial. So, 5 into 4 factorial. Or, if I take 5 and 4, If I take 5 and 4, what's the remaining? 1 into 2 into 3, it is what? 3 factorial. So you can write 20 factorial as 20 into 19 factorial, or 20 into 19 into 18 factorial, or 20 into 19 into 18 into 17 factorial. Like this you can write. What's the use of this, Suppose if we have, suppose say 10 factorial by 8 factorial, you can't cancel factorial, 8 and 10, 2 table. No, you cannot do like that, okay? So here, denominator is 8 factorial. Using the above result, 10 factorial can be reduced, right? Denominator is 8 factorial, so till you get 8 factorial, you can write. So 10 factorial can be written as 10 into 9 factorial, or 10 into 9 into 8 factorial, or 10 into 9 into 8 into 7 factorial. But here we stopped with 8 factorial. You can cancel it now, no? So the calculation part, it will be useful. Okay, this is another result. Now listen, another important thing. Suppose you have 1 into 2 into 3 into 4 into 5, that is what? That is 5 factorial. Okay, so that is 5 factorial. Suppose with this 1 into 2 into 3 into 4 into 5, if I multiply 6 also, so 5 factorial, that is 1 into 2 into 3 into 4 into 5, 5 factorial into the next number. What's the next number? 6. So that means 5 factorial means 1 into 2 into 3 into 4 into 5 into what you have? 6. So 1 to 6 continuously you have, then your answer is what? 6 factorial. 5 factorial into 6 into 7. So 5 factorial means 1 to 5. Then in addition to that you have 6 and 7. Then your answer is what? 7 factorial. So please listen here. 10 factorial into 11 into 12 into 13. What's your answer? 13 factorial, because continuity is there, right? Suppose 7 factorial into 9 into 10 into 11 into 12. What is your answer? Some of you are telling it is 12 factorial, right? No, it is not 12 factorial. Why? There is no continuity. After 7 factorial, you should get what? 8. 8 is missing. Then you write 12 factorial by 8 you can write. Okay? Okay, good. So now what you have to understand here, suppose n factorial into the very next number. After n, the next number is n plus 1. Then what's your answer? N plus 1 factorial. It is like 5 factorial into 6. It is 6 factorial. If I take one more, n factorial into n plus 1 into n plus 2, the answer is what? N plus 2 factorial. And the previous result, what I said, n factorial can be written as 5 factorial is 5 into 4 factorial. 5 into 4 into 3 factorial. That is, n factorial can be written as n into, you reduce 1, n minus 1 factorial. Or can be written as n into n minus 1 into n minus 2 factorial, and so on. Okay. So these are some of the very, very important results in factorial. So if you know factorial, then only you can learn permutation and combination, because there we have some formula. For the calculation purpose, you need all these things. Okay. Now let's move on to permutations. Let us study that in detail. Already I said permutation means it is what? Arrangement, right? So here the order is important. In one example, first I said no. So totally there are 3 books. 3 books you are arranging 2 at a time. So that can be written as 3p2. So first number represents the total. Totally there are 3 books. You are taking 2 at a time and you are arranging. That can be written as 3p2. Suppose there are n objects. So you are taking r at a time. You are taking r at a time and you are arranging. Then it can be done in NPR ways. It can be done in NPR ways. In the previous one is 3p2. Hope you're remembering. 6 ways you got it, right? So 3p2, the value is 6. How we got 6? That we will study. Okay. Some small example, okay, you can write and see that. Right? But here you cannot do like that for every sum, right? So you have some standard results. Some of the formula, NPR, the basic formula what you study, NPR is equal to n factorial by n minus r factorial. NPR, the formula is n factorial by n minus r factorial. So please listen to a small example you see. Suppose you want 10p2. 10p2. So by this formula, NPR is n factorial by subtract n minus r factorial. So that's the reason factorial is important, right? So n factorial here, instead of n we have 10. So 10 factorial by n minus r, that is 10 minus 2. What is 10 minus 2? 8. Can be simplified, right? 10 factorial, 1 into 2 into 3. But no need. If you are thorough with factorials, you can go for the shortcut method, right? Denominator 8 factorial, right, as it is. Numerator 10 factorial is 10 into 9 into 8 factorial. 8 factorial cancel, 10 into 9, your answer is what? 90. But now, actually this is the formula. NPR is equal to n factorial by n minus r factorial. Calculation you have to do like this. But I am going to teach you another very simple method. Please listen. After simplification, you are getting only 10 and 9, right? Only 10 and 9. So 10p2. 10p2 means 10 into 9. What we are doing here actually, starting with 10. Starting with 10, reducing 1 by 1. How many terms you write? 2 terms you write. Okay, now please listen. Can you guess what is 10p4? Start with 10, reduce 1 by 1, write 4 terms. Even if you use the formula, you will get the same thing. Okay, so when you do the calculation, you can do it straight away like this. But the formula, remember, it will be useful in so many places. 10p4, start with 10, 10 into 9 into 8 into, keep on writing. But how many times you write? See the second number, 4. You are supposed to write only 4 times. 10 into 9 into 8 into 7. So 20p3, what is that? 20 into 19 into 18, right? So you can do like this. The calculation part you can do like this. So once again you see NPR. What's the formula? N factorial by n minus r factorial. Please remember the first number must be greater always. Because from 10 you can take 1 or 2 or 0 or even 10, right? From 10 you cannot take 20, right? So second number must be, r must be less than what? N, or it can be even equal to n. From 5 you can take 5, right? From 5 you cannot take 6. So second number cannot be more than the first number, and it must be a whole number also, right? Okay, so this is the basic formula. Now instead of r, if I put n, instead of r I put n. So npn. npn. So what is that? N factorial. Denominator you see, for r you give n. n minus n, 0. 0 factorial. What is 0 factorial? 1. So n factorial by 1. So npn, the answer is what? N factorial. What is np1? Use this method. Start with n. Write 1 term. That's all. So np1 is equal to what? N only. What is np0? np0, that means for r you put 0. Numerator is n factorial, denominator r is 0, so you are getting n factorial, cancel, you are getting 1, right? For objective questions, you remember all these. np0 is equal to 1, n equal to n factorial, so 5p5. What is 5p5? 5 factorial, right? So npn is n factorial, so 5p5 is 5 factorial. What is 5p0? 1. What is 5p1? It is 5, right? Start with 5, write only 1 term. Okay, so all these things you remember. The next what you need, I'm going to give a set of formula. Please listen this one. 3 results. Number of ways, suppose n objects are given. N objects are given. In how many ways you can arrange? N objects. Number of ways n objects can be arranged in a row, in a line. You want to arrange n objects in a row, it can be done in n factorial ways. It can be done in n factorial ways. So our 5 objects can be arranged in 5 factorial ways in a line. But if you want to arrange them in a circle, that is called circular permutation. Reduce 1. Here the answer is n minus 1 factorial. Factorial ways you can arrange. Okay, so n objects. If you want to arrange them in a line, it can be done in n factorial. Same n objects, if we want to arrange them in a circle, then that is called circular permutation. It can be done in n minus 1 factorial ways. Third one, circle only, but all the objects are exactly alike. You are not able to distinguish them. Everything looks similar. Okay, then that can be done in n minus 1 factorial, because it is a circle, by 2 ways. So take these 3 as formula. Okay, it will be useful for a lot of some competitive exams also. Okay, so n objects are given. These n objects can be arranged in a line in n factorial ways, in a circle n minus 1 factorial ways, in a circle, and they are all exactly alike. That can be done in n minus 1 factorial by 2. See some examples. 7 students standing in a line for school assembly. 7 students standing in a line. So it can be done in which type? First type, right? N factorial. So here it is 7 factorial. 7 students standing in a line, okay, in a row. Four members in a family sitting around a table. In a family, there are four people. They are sitting around a table for dinner, sitting around. So it is a circle, right? In circle, two formulae given. One is exactly alike. But here, four members of a family, they won't be looks alike, right? So here, circular permutation, n minus 1 factorial. Here, 4 minus 1. So the answer is what? 3 factorial. Another one you see, 51 flowers in a garland. Suppose some rose garland, okay? There are 51 flowers. How many ways you can arrange? 51 rose flowers. So everything looks similar, right? You cannot easily distinguish them. So it is a garland. So it is a circle. And they're all exactly alike. So the formula what it uses is n minus 1 factorial by 2. So what is n here? 51. So 51 minus 1, 50 factorial by 2. Can you simplify? Don't cancel it. You can't do that. Okay, just leave it. Suppose same way in a keychain. Keychain means, it is a circle, right? Circular permutation. Similar keys means, okay, exactly like otherwise n minus 1 factorial. Okay, so with this idea, you can do sums in what? Permutation. And here there are a lot of questions. Word sums are there. See, suppose you have maths. How many ways you can arrange the letters? See how many letters are there? 1, 2, 3, 4, 5. There are 5 letters. They can be arranged in 5 factorial ways. See whether there is any repetition, no repetition. If there is no repetition, that's all, 5 factorial. There are 5 letters, can be arranged in 5 factorial ways. Suppose I am taking OT. How many letters are there? 4 letters. So they 4 letters can be arranged in 4 factorial ways. If there is no repetition, that's your answer. But here, O repeats 2 times, right? O repeats 2 times. So denominator you write 2 factorial. Suppose another letter or 2 repeats 2 times means another into 1 more 2 factorial. Okay, like that you have to do. Okay. So more sums I'll help you in some other video. So here only mainly the concepts, what are the formula and how to use the formula. Okay. Same way the digit sums they can ask. Say using the digits, say 1, 2, 3, 4, 5. How many 3-digit numbers can be formed? So here 2 type of questions. One is repetition allowed. Another one repetition not allowed. Repetition allowed, repetition not allowed. Repetition allowed. So one number can be used any number of times. Totally you have 5 numbers, right? So this place can be filled in 5 ways. Then this can be filled in 5 ways. This can be filled in 5 ways. So your answer is 5 into 5 into 5. But if they say repetition not allowed, so one number here, the first place, you can fill in 5 ways because you have all the 5 numbers with you, right? So one number we used, that number cannot be used now because repetition not allowed. So you have only 4 now. So this can be filled in 4 ways. 2 numbers we used, we have only 3. So this can be filled only in 3 ways. You can go in any order from left to right or right to left, no problem. But if 0 is a number given, you have to be very careful because in hundreds place cannot be 0. If you put a 0 there, then it become a 2-digit number. You have to be very careful in this. So here 5 into 4 into 3 you have to multiply. Okay, so these type of questions you can expect in permutations. Hope you understood all the results in permutation. Now I'm going to explain results in combination, right? So when we use combination, whenever just selection is required, right? Whenever selection is required, we make use of what? Combinations. Okay, so now listen. Total n objects you want to select R at a time. Arrangement means permutation. Here selection, combination. N objects you are selecting R at a time, denoted as NCR. Instead of NPR, it is what? NCR. You are remembering the formula for NPR? N factorial by N minus R factorial. But NCR, there is a formula, N factorial by R factorial. You can remember easily. N factorial by R factorial into N minus R factorial. In the denominator, N minus R factorial. Permutation, N factorial by N minus R factorial. There is a relation between permutation and combination. See what it is? See this part. N factorial by N minus R factorial, that only permutation, right? So that is NPR. By denominator we have R factorial. This is NCR. So NCR is equal to NPR by R factorial. This is the relation between permutation and combination. Now let us see how to do sums. Suppose I want 5C2. If I apply the formula directly, what's the formula? NCR, N factorial by R factorial into N minus R factorial. So here 5 factorial by 2 factorial into 5 minus 2, that is 3. 3 factorial can be simplified, right? 5 factorial, 5 into 4 into 3 factorial, because denominator there is a 3 factorial, no? Then here 2 factorial means 1 into 2. 3 factorial cancel, 2 table you cancel, so 5 2's, your answer is what? 10. Now listen, but there is an easy method. Permutation we did a simple method, no? 5p2 means start with 5, reduce 1 by 1, only 2 times you write. Same way for combination, if I want 5c2, you start with 5. Reduce 1 by 1, write only 2 times first, okay? That is 5 into 4. Permutation means we write only up to this, okay? But combination means it is permutation, don't stop there. By r factorial, second number factorial. Here what is second number? 2. So denominator you write 2 factorial. So your answer is what? 10. So same answer you can do in the simple way. So now please listen, what is 10C3? Permutation means 10 into 9 into 9 into 8. Combination means 10 into 9 into 8 by, since 3 is there, 3 factorial, 1 into 2 into 3. So you know how to simplify that, right? Suppose 20C17. First we studied formula. In some cases formula may be little lengthy, so we got some easy method. But even that easy method is not easy here, right? Because 20C17 means you start with 20, reduce 1 by 1, you have to write 17 times. Denominator you write 17 factorial. But please listen, that's the beauty of mathematics. Whenever you find something difficult, they find some new result. There is a result, listen. There is a result, the result is NCR is equal to NC n minus R. NCR equal to NC n minus R. Listen, NC, no change. NC, here also NC. Instead of R, what you are writing? N minus R. Let us see, we did here something, no? 5C2. If I use the result, 5C2 can be written as 5C. NCR. NCR can be written as NC. Don't write R, you write N minus R. 5 minus 2. What is 5 minus 2? 3. Let us see, are they same? 5C2 can be written as what? 5 into 4 into 3, right? Because 3 times. By 1 into 2 into 3. 3 cancel, 2 table cancel, 5 into 2, 10. Yes, both answers are same. 5C2 and 5C3 are same. So NCR and NC n minus R are same. So 20C17 can be written as 20C. Don't write 17. Instead of 17, you subtract them. N minus R, 20 minus 17. What is 20 minus 17? 3. Now the calculation is easy, no? 20C3. What is 20C3? 20 into 19 into 18 by 1 into 2 into 3. So, but when to use this? Don't you try to use every time. Suppose you have, say, 12C5. Don't try to use it. If you use 12C5, what you get? 12C, 12 minus 5, 7. That is little more tough. 7 times you're right. So when you have to use, when the second number is more than half of the first number. Okay. So if 12 means 12C, up to 6 it's okay directly. Suppose if 7 comes, use this formula. 8 comes, use this method. Okay. Otherwise, do directly. Okay. So that is one formula you have to remember. Then another one, suppose if we have NC0. You know the formula for NCR, right? What is NCR? N factorial by R factorial into N minus R factorial. You study the relation between permutation and combination. NC0 means for R you put 0. So this is 0 factorial. Okay, 1. Here 0 you give N factorial. N factorial cancel. Your answer is what? 1. NC0 is 1. NCN, you see, what is NCN? For R you give N. So numerator is N factorial. Here R you are giving N. So N factorial, N minus N is what? 0 factorial is 1. Cancel. Your answer is what? 1. NC1 is N. Start with N, write one term. Denominator 1 only. Okay. So these values you have to remember. Now the next one what I want to give you, listen. Suppose if I have somewhere N factorial is equal to 5 factorial. You can compare both factorials only, 2 raised to n equal to 2 raised to 7. Same type. So immediately you say n is equal to 7, right? Here n factorial equal to 5 factorial. Both the sides factorials only. You will say definitely n is equal to what? 5. So here in combination, suppose you have NCA equal to NCB. What can you say? Some of you are thinking A equal to B, right? Yes, A equal to B. Not always, because now you see these two are equal. Which two? Yes, these two are equal, right? 12C5 equal to 12C7. Both look similar. 12C5, 12C7. NCA, NCB. A and B are not equal. 5 and 7 are not equal. But what is 5 plus 7 is equal to what? 12. So now please listen here. NCA equal to NCB means, NCA is equal to NCB means either A is equal to B or A plus B is equal to N. Remember, NCA equal to NCB means two options. Either A is equal to B, not always. If not, then A plus B is equal to what? N. Okay, so that you remember. Then next one I want to teach you, when can you add two combinations? How to add two combinations? You can't simply add two combinations, any two combinations. There is some conditions. I'll tell you. Please listen. 5C2 plus 5C3. You can add it. 10C7 plus 10C8. You can add it. 20C12 plus 20C11. You can add it. Can you see something here? Please listen. First numbers same. First numbers same. First number same, right? Okay. Second number, if you see, 2 and 3. 7 and 8. 11 and 12. So first numbers must be same. Second numbers must be consecutive numbers. Then you can add it. You can't simply add any two combinations. First numbers must be same. Second numbers must be two consecutive numbers. Then you can add it. How to add? First number you add one more. First numbers are same, right? You add one more. Here 5 and 5. So add 1, 6. C. Second number, two consecutive numbers. Among that two, you see which is the greater number. 2 and 3. Which is greater? 3. So your answer is 63. Here, first numbers are same, 10. So you write to add one more. So write 11C. Second number 7 and 8. 7 and 8. Greater number 8. So 7C, 11C, 8. Next one 20. So you write 20 here. No, it's not 20. Add one more, right? 21C. 11 and 12. Greater number is what? 12. So your answer is 21C, 12. Now please listen. I'll give a very small question. Try to answer. If you're answering correctly, yes, you understood this one. Okay. Please listen. 8C4 plus something is equal to 9C4. 8C4 plus something is equal to 9C4. Can you try to find out the value? Yes. See what you get. You are going to add two combinations, right? So first numbers must be same. Here 8 means here also it must be 8C. Second number must be consecutive numbers, right? Here 4. So 4 and 5 are 4 and 3. 3 and 4 also consecutive numbers. No, order can be changed any order because plus only in between, right? So first numbers must be same. So 8C. Here also it should be 8C. Second one, consecutive number. 4 is given. Its consecutive number means either the next one or the previous one. 4 and 5 or 3 and 4. How can you decide whether the answer is 3 or 5? See the answer. Your answer is among that two the greater number, right? If I write 5 here, you can add it. But the second number, the greater number is 5. Your answer should be 9C5. But here 9C4 only given, right? So here you write 3. Then only two consecutive numbers, 3 and 4. Consecutive numbers. Among that two, the greater number is what? 4. Are you able to understand it? Yes. Like this you can add it. So suppose if you have NCR plus, first number must be same. NCR plus 1. Then what should be your answer? First numbers are same. Check whether can you add it. Yes, first numbers are same. Second number is two consecutive numbers, R and R plus 1, right? So you can add it. When you add first number, you add one more. That is N plus 1. C. Second number, write the greater one. R and R plus 1. The greater number is what? R plus 1. Okay, so hope you understood how to add two combinations. Okay. Now listen. In permutation, I taught 3 results, no? Suppose n objects can be arranged in a row, n factorial in a circle, n minus 1 factorial in a circle and exactly alike n minus 1 factorial by 2. Same way here. If you go some maths exhibition and all, sometimes you can see some picture like this. Say some points will be there and they would have drawn some lines and all, right? And they will ask you as a game, they'll ask you to count how many lines are there. Some people will be just stand before that and they will be starting what? Counting the number of lines and all. Okay, so that is not easy one. Okay, so that's not easy one. So all these you can do using our permutations and combinations. Okay, so now listen here. Suppose n points are given. N points. N points are given. What is the specialty? No 3 points are collinear. No 3 points are collinear. Collinear means they lie in a same line. Suppose the points are lying in a same line means how many lines you can draw? Only one line, right? So there this method is not possible. Okay. So n points are given. No 3 points are collinear. Then how many lines you can draw? N points are given. How many lines you can draw? Please listen. Some points are given. To draw a line, you have to connect how many points? You have to connect 2 points, right? So you have select 2 points at a time. So n points are given. How many lines are there means your answer is NC2. So in that case, just you have to count how many vertices are there. Check whether every vertex is joined. Then you apply the formula. Suppose there are 10 points are there. Then 10C2. Just you have to do the calculation. That's all. No need to stand and count number of lines. Okay. Then how many triangles are there? How many triangles are there? To draw a triangle, how many points you have to connect at a time? 3 points, right? If you join 3 points, you'll get a triangle. Totally there are n points. So from that n points, you take 3 points at a time. So, but here only selection only. See, you are joining ABC. It is triangle ABC or is a triangle BCA or triangle CAB. Everything same only here. Order is not important. Just we are selecting, right? That's all. So n points are given. How many lines? NC2. How many triangles? NC3. How many diagonals are there? Diagonals are also lines only, right? Diagonals are also lines only. But all the diagonals are not lines, right? All the diagonals are not lines. So all the lines are not diagonals because some lines are what? Sides. Some lines are sides. These are all sides, right? Sides cannot be the diagonal. Other lines only the diagonal. So from the total number of lines, how many lines are there? NC2 lines. From that, you remove the sides. How many sides will be there? If there are 3 points, 3 sides. If there are 4 points, 4 sides. If there are 1, 2, 3, 4, 5 points, 5 sides, right? 1, 2, 3, 4, 5. If there are n points, n sides will be there. So remove the sides. Total number of lines, remove the number of sides, you will get the diagonals. Because all the lines except the sides are what? Diagonals. Okay, this is very important one. Suppose n points are given. How many lines can be drawn? NC2. How many triangles can be drawn? NC3. How many diagonals are there? NC2 minus n. Okay, so with this I'll give a very small sum. Look at this. A polygon. Polygon means many-sided closed figure. A polygon has 90 diagonals. They didn't ask you how many diagonals. It is given. A polygon has 90 diagonals. Find the number of its sides. How many sides will be there? Or how many points are there? Both same only, right? How many sides are there? Number of diagonals is 90, right? What's the formula for number of diagonals? NC2 minus n is equal to what? 90. So here n stands for number of points. Suppose there are 5 points, 5 sides. Okay. Let us find n value. NC2 means no need to apply the formula. Start with n, reduce 1 by 1, write 2 terms. Then since 2 is there, denominator you write 2 factorial. So n into reduce 1, n minus 1 by 2 factorial. 2 factorial means 1 into 2, it is 2. Minus n is equal to 90. Take 2 as LCM. So multiply n into n square minus n into 1 n minus when you take LCM this becomes 2n is equal to 90. Cross multiply n square minus 3n equal to 180. Bring it to the left side. Minus 180 is equal to 0. Sum is minus 3. Product is minus 180. numbers are minus 15 and 12. So n minus 15 into n plus 12 equal to 0. So n equal to what? 15. N equal minus 12, that is not possible. So n equal to 15, that means there are 15 vertices. If there are 15 vertices, number of sides also what? 15. Find the number of sides. Okay. So hope you understood all these formula, right? So if you are thorough with the formula, definitely you can do the sums very easily. Okay. And here another very important thing what I want to teach, how to find rank of the word. That I will help you in the next video. We'll continue in the next video.